The 2022 Atlantic hurricane season is the current cycle of the annual tropical cyclone season in the Atlantic Ocean in the Northern Hemisphere. The season officially began on June 1, and will end on November 30. These dates, adopted by convention, historically describe the period in each year when most subtropical or tropical cyclogenesis occurs in the Atlantic Ocean. This year's first named storm, Tropical Storm Alex, developed 5 days after the start of the season, making this the first season since 2014 not to have a pre-season named storm. There have been 12 named tropical storms so far in the season. 5 of them strengthened into a hurricane, and 2 reached major hurricane intensity. In July, Tropical Storm Bonnie formed and quickly made landfall along the Costa Rica-Nicaragua border. It then crossed over into the Pacific Basin a day later, becoming the first to survive the crossover from the Atlantic to the Pacific since Hurricane Otto in 2016. The same day as Bonnie's crossover, Tropical Storm Colin unexpectedly formed inland over coastal South Carolina. It quickly weakened and dissipated the next day after moving into coastal North Carolina. Following this activity, tropical cyclogenesis was suppressed across the basin for several weeks by a combination of high wind shear, drier air, and the presence of the Saharan air layer. As a result, this was the first season since 1997 in which no tropical cyclones formed in August, and the first season on record to do so during a La Nina year. After a 60-day lull in tropical cyclone activity, Hurricanes Danielle and Earl formed on September 1 and 3 respectively, with Danielle becoming the season's first hurricane. The last season to have its first hurricane develop this late was 2013. Activity then increased tremendously towards the end of the month as 4 named storms formed in quick succession. Among them, Hurricane Fiona became the season's first major hurricane on September 20, which is about 3 weeks later than when the first one typically forms. Hurricane Ian became the second major hurricane of the season on September 27, before inflicting major to catastrophic damage upon western Cuba, southwestern and central Florida, and the Carolinas. Hurricane Julia formed in early October and became the second storm of the season to cross over into the Pacific Basin intact after traversing Nicaragua. Seasonal forecasts. In advance of, and during, each hurricane season, several forecasts of hurricane activity are issued by national meteorological services, scientific agencies, and noted hurricane experts. These include forecasters from the United States National Oceanic and Atmospheric Administration's Climate Prediction Center, Tropical Storm Risk, the United Kingdom's Met Office, and Philip J. Klotzbach, William M. Gray and their associates at Colorado State University. The forecasts include weekly and monthly changes in significant factors that help determine the number of tropical storms, hurricanes, and major hurricanes within a particular year. According to NOAA and CSU, the average Atlantic hurricane season between 1991 and 2020 contained roughly 14 tropical storms, 7 hurricanes, 3 major hurricanes, and an accumulated cyclone energy index of 70/111 units. Broadly speaking, ACE is a measure of the power of a tropical or subtropical storm multiplied by the length of time it existed. It is only calculated for full advisories on specific tropical and subtropical systems reaching or exceeding wind speeds of 39 miles per hour. NOAA typically categorizes a season as above average, average, or below average based on the cumulative ACE index, but the number of tropical storms, hurricanes, and major hurricanes within a hurricane season is sometimes also considered. Pre-season forecasts. On December 9, 2021, CSU issued an extended range forecast for the 2022 hurricane season, giving a 40% chance of near-average activity with 13-16 named storms, 6-8 hurricanes, 2-3 major hurricanes, and an ACE index of about 130 units. The forecast also gave a 25% chance that the ACE index would end up being around 170 units, and a 25% likelihood that the index would end up around 80. TSR also issued an extended range forecast on December 10, 2021. It predicted overall near-average tropical activity with its ACE index, anticipating 18 tropical storms, 8 hurricanes and 3 intense hurricanes to form during the season. One of their factors was the expectation of a neutral El Niño southern oscillation condition by the third quarter of 2022. This outlook had large uncertainties. On April 7, CSU issued their first extended range seasonal forecast for the 2022 Atlantic hurricane season, predicting well above average activity, with 19 named storms, 9 hurricanes, 4 major hurricanes and an ACE index of 160 units. Their factors supporting an active hurricane season included above-average sea surface temperatures in the subtropical Atlantic Ocean and Caribbean Sea, and a cool neutral ENSO or weak La Niña pattern, corresponding to a low chance of an El Niño. On April 14, 2022, University of Arizona issued its seasonal prediction for a slightly above-average hurricane season, with 14 named storms, 7 hurricanes, 3 major hurricanes, and an ACE index of 129 units. North Carolina State University made its prediction for the season on April 20, calling for an above-average season with 17 to 21 named storms, 7 to 9 hurricanes, and 3 to 5 major hurricanes. On May 23, UKMO issued their own forecast for the 2022 season, predicting an above-average season with 18 named storms, 9 hurricanes, and 4 major hurricanes, with a 70% chance that each of these statistics will fall between 13 and 23, 6 and 12, and 2 and 6, respectively. The following day, NOAA's Climate Prediction Center issued their forecasts for the season, predicting a 65% chance of above-average activity and 25% chance for below-average activity, with 1421 named storms, 610 hurricanes, and 36 major hurricanes. Mid-season forecasts. On June 2, CSU updated their extended range seasonal forecast, increasing the amount of tropical cyclones to 20 named storms, 10 hurricanes, 5 major hurricanes, and an overall ACE index of 180 units. This was done after later analysis of lower chances of an El Niño during the season, as well as a warmer-than-average tropical Atlantic. On June 20, 2022, University of Arizona updated its seasonal prediction, which is very similar to its April prediction, with 15 named storms, 7 hurricanes, 3 major hurricanes, and an ACE index of 131 units. On July 5, TSR released their third forecast for the season, slightly increasing their numbers to 18 named storms, 9 hurricanes, and 4 major hurricanes. This prediction was largely based on the persistence of the weak La Niña into the third quarter of the year. On July 7, CSU did not make changes to their updated prediction of 20 named storms, 10 hurricanes, and 5 major hurricanes. UKMO's updated forecast on August 2 called for 16 named storms, 6 hurricanes, and 4 major hurricanes. 2 days later, NOAA and CSU each revised their activity outlook slightly downward, though both still predicted that the season would end up being busier than the 30-year average. The revisions were made in part because of the relative slow start to the season, with only 3 short-lived named storms as of the start of August. Seasonal summary. The 2022 season was the first season since 2014 to not have a pre-season named storm. Activity began with the formation of Tropical Storm Alex on June 5, after several days of slow development while traversing the Gulf of Mexico and then moving over central Florida. The storm peaked at near hurricane strength before becoming extratropical over the central North Atlantic. At the beginning of July, Tropical Storm Bonnie formed in the southern Caribbean Sea and made landfall shortly thereafter near the Costa Rica-Nicaragua border. It then crossed over into the Pacific Basin a day later, the first storm to do so since Hurricane Otto in 2016, where it would become a Category 3 hurricane. On the same day that Bonnie crossed over, a low-pressure system over coastal South Carolina abruptly organized into Tropical Storm Colin, a short-lived storm that dissipated the next day over eastern North Carolina. Tropical activity then ceased, with no tropical cyclones forming for almost 2 months. 2022 became the first season to not have a tropical cyclone form in August since 1997. One disturbance over the Gulf of Mexico during the middle of the month was briefly designated as a potential tropical cyclone, but it did not organize into a tropical cyclone before moving inland over northeastern Mexico. Tropical activity ultimately resumed with the formation of Tropical Storm Danielle over the central Atlantic on September 1. The storm intensified into a hurricane the following day, the latest first hurricane of the season since 2013. It remained nearly stationary far to the west of the Azores for several days before moving northeastward and becoming extratropical on September 8 without affecting any land areas. Additionally, a slow-developing disturbance east of the Lesser Antilles became organized and developed into Tropical Storm Earl late on September 2-3. It strengthened into a hurricane, tracked east of Bermuda, fluctuating between Category 1 and 2 intensity, and then became extratropical near Newfoundland on September 10. 4 days later, Tropical Storm Fiona formed in the central Atlantic. Fiona eventually became a hurricane, striking both Puerto Rico and the Dominican Republic before becoming the season's first major hurricane as it passed by the Turks and Caicos Islands on September 20. That same day, Tropical Storm Gaston formed over the central Atlantic. Fiona would strengthen into a Category 4 hurricane as it passed west of Bermuda while Gaston would strike the Azores. As Fiona transitioned into a powerful extratropical cyclone that would strike Nova Scotia on September 23, Tropical Storm Hermine and Tropical Depression 9 formed in the eastern Atlantic and the Caribbean Sea respectively, marking the first time since 2020 that 4 tropical cyclones were active simultaneously in the Atlantic Basin. Hermine, one of the easternmost Atlantic tropical storms on record, brought heavy rainfall to the Canary Islands. Tropical Depression 9 rapidly strengthened into Hurricane Ian, which made landfall in western Cuba as a high-end Category 3 hurricane, southwestern Florida as a high-end Category 4 hurricane and in South Carolina as a Category 1. Next, Tropical Depression 11 formed during the last week in September, and then Tropical Depression 12 formed 1 week later. Ultimately, neither cyclone strengthened into a tropical storm. Soon thereafter, Hurricane Julia formed just off the coast of Venezuela. After traversing Nicaragua intact, Julia entered the Pacific Basin. Not since 1996 has more than one storm crossed between the Atlantic and Pacific Basins intact during a single season. On October 11, Tropical Storm Carl formed in the Bay of Campeche. This season's ACE index as of 1500 hours UTC on October 31, as calculated by Colorado State University using data from the NHC, is approximately 84.4 units. This number represents the sum of the squares of the maximum sustained wind speed for all named storms while they are at least tropical storm intensity, divided by 10,000. Therefore, tropical depressions are not included. Systems. Tropical Storm Alex. On May 31, a large low-pressure area developed near the Yucatan Peninsula, partially related to the Pacific Basin remnants of Hurricane Agatha interacting with an upper-level trough over the Gulf of Mexico. The low moved eastward over the Yucatan Peninsula, producing a large area of disorganized showers and thunderstorms over the peninsula and northwestern Caribbean Sea on June 1-2. Due to the threat the developing system posed to Cuba, the Florida Keys and South Florida, the National Hurricane Center initiated advisories on it, designating it as potential tropical cyclone 1 at 2100 hours UTC on June 2. As it proceeded northeastward over the Gulf of Mexico, the disturbance was being buffeted by 25-35 mph southwesterly shear, which limited its ability to intensify. On June 3, 2 Hurricane Hunters missions into the system found deep convection ongoing near and to the east of the estimated center, but no conclusive evidence of a closed circulation. Early the following day, the broad and poorly defined center of the disturbance moved over southwestern Florida. Then, after moving into the Atlantic later that same day, a well-defined center formed with sufficient convection, resulting in it being upgraded to Tropical Storm Alex at 6 o'clock UTC on June 5. The storm intensified some later that same day, attaining sustained winds of 70 miles per hour as it passed west of Bermuda. Soon thereafter, Alex began its extratropical transition, a process that was complete by 2100 hours UTC on June 6. Several days later, the system passed to the west of Scotland and near the Faroe Islands, before rapidly weakening while moving toward Norway, which it reached on June 13. While a potential tropical cyclone, what would later become Alex produced significant rainfall across western Cuba and South Florida, which resulted in flash flooding across both regions. During a 30-hour period on June 2-3, Paso Real de San Diego in the province of Pinar del Rio recorded about 12 inches of rain, and Playa Girón in Matanzas received over 8 inches. There were 4 storm-related deaths in Cuba, and numerous homes and bridges were damaged by the flooding. Between 7 a.m. local time on June 3, and 10 p.m. the following day, Miami saw just over 11 inches of rain, while Hollywood had just over 9 inches. Naples, near where the storm's estimated center came onshore, also had close to 9 inches. Across Broward County and Miami-Dade County, there were a combined 3,543 power outages. Tropical Storm Bonnie. A tropical wave moved off the northwest coast of Africa south of 10 degrees north on June 23, producing a large but disorganized area of showers and thunderstorms. The low-level wind circulation associated with the system became better defined and thunderstorm activity increased on June 25-26, as it moved along a west-to-west-northwesterly track toward the southernmost Windward Islands. A NOAA Hurricane Hunters mission on June 27 reported tropical storm-strength winds on the north side of the disturbance, but indicated that it had not yet shown a well-defined closed circulation. Although it could not yet be classified as a tropical cyclone, due to the threat the system posed to the Lesser Antilles, the National Hurricane Center initiated advisories on it as potential tropical cyclone 2 later that same day. Later, after moving through the southern Windward Islands late on June 28, the disturbance sped west at 26 miles per hour toward the coast of South America. Over the next couple of days, the system passed just to the north of Venezuela, where it was hindered from developing a distinct low-level circulation due to its fast forward speed and its interaction with land. Yet all the while it generated sustained winds of tropical storm strength. As the disturbance moved toward Central America on the morning of July 1, it became sufficiently organized to be classified as a tropical storm and was given the name Bonnie. Embedded in a low shear and warm SST environment, Bonnie started to steadily intensify. At 3 o'clock UTC on July 2, Bonnie made landfall near the Costa Rica-Nicaragua border at its peak intensity within the Atlantic with sustained winds of 50 miles per hour. Bonnie then crossed Central America and exited into the eastern Pacific Basin 12 hours later. Bonnie and its precursor disturbance produced gusty winds and heavy rainfall as it tracked through the southern Caribbean Sea. In Nicaragua, authorities reported 4 deaths in relation to the storm. Tropical Storm Colin. An area of low pressure formed offshore of Savannah, Georgia, on the morning of July 1, and moved inland across coastal South Carolina later that same day. During this time the system unexpectedly developed with persistent deep convection forming close to the center and quickly becoming well organized. On July 2, at 9 o'clock UTC, Tropical Storm Colin formed about 50 miles southwest of Myrtle Beach, South Carolina, with sustained winds of 40 miles per hour and an estimated central pressure of 1011 bar. The storm became increasingly disorganized later that day, with its circulation becoming elongated from north-northeast to south-southwest due to high wind shear and continued land interaction. By 3 o'clock UTC on July 3, after passing Wilmington, North Carolina, Colin had weakened to a tropical depression. The system dissipated over eastern North Carolina 9 hours later. Most of Colin's heavy rains and strong winds remained out over the Atlantic due to its proximity to the coast and northwesterly shear of around 25 miles per hour. Rainfall totals inland ranged from 2–3 in parts of the Midlands of South Carolina to near 7 in near Charleston, South Carolina. A 4th of July weekend event in Charleston was cancelled because of flooding at the event site, as was a festival in Southport, North Carolina. One person drowned off the coast of Oak Island after being pulled out by rip currents. Hurricane Danielle. On August 30, an area of low pressure formed along a decaying frontal zone over the central subtropical Atlantic. The disturbance quickly organized and developed into Tropical Depression 5 early on September 1 before strengthening into Tropical Storm Danielle later that evening. The storm continued to strengthen and became a Category 1 hurricane on September 2. It stalled the following day, caught south of a blocking high, and weakened back into a tropical storm due to upwelling of cooler waters and some dry air. Later, the storm began drifting toward the west, where it again strengthened into a hurricane overnight September 3–4. After turning northwestward, Danielle reached its peak intensity with sustained winds of 90 miles per hour early on September 5. It then moved over a relatively cool part of the Gulf Stream and weakened to a low-end Category 1 hurricane. Danielle briefly re-intensified when it moved over marginally warm waters on September 7, but resumed a weakening trend shortly afterwards. Danielle weakened to a tropical storm on September 8 before transitioning into an extratropical cyclone later that day. Large waves and heavy rain hit the Azores. Danielle made an extratropical cyclone landfall in Portugal, bringing heavy rain to the country. Between September 12–13, 644 accidents were reported throughout the country. Many downed trees and flash floods were reported. In Mantegas, floods and landslides caused major damage. 4 vehicles were dragged into the Zazir River. Heavy rain extended to as far out as Braga. Cuvilha saw 67.2 mm of rain while Viçu saw 62 mm of rain. Minor wind and flooding damage was reported in both Lisbon and Setúbal. The Portuguese government issued a state of calamity after Danielle passed by. Spain saw heavy rain when Danielle hit. Hurricane Earl. A tropical wave producing widespread disorganized showers and thunderstorms moved off the west coast of Africa on August 25. After moving across the eastern and central tropical Atlantic, the disturbance encountered environmental conditions east of the Leeward Islands that were only marginally conducive for tropical cyclone development. After struggling against high wind shear for several days, the disturbance was finally able to become better organized and developed into Tropical Storm Earl early on September 3. A burst of deep convection occurred near Earl's center during the evening of September 5, and a hurricane hunter's mission into the storm later that night reported that it briefly strengthened to very near hurricane strength. Earl's intensity continued to fluctuate throughout much of the next day due to continued effects of westerly deep layer shear. Later that day, the shear began to quickly diminish, and Earl became better organized, strengthening into a hurricane around midnight UTC on September 7. By 3 o'clock UTC on September 8, Earl reached Category 2 strength while moving northward. Hurricane Hunter's data showed it to have an eye of almost 60 miles and a fairly symmetric wind field. 3 hours later the hurricane attained peak sustained winds of 105 miles per hour. Despite being forecasted to continue strengthening into a Category 4 hurricane, Earl's inner core was repeatedly interrupted due to dry air entrainment and it fluctuated in strength the following day while passing well to the east of Bermuda despite being over very warm sea surface temperatures of around 84–86 degrees F. It briefly weakened to Category 1 strength early on September 9, before rebounding to Category 2 strength with a peak intensity of 105 miles per hour sustained winds and a minimum barometric pressure of 954 bar. At this time, Earl had become a large hurricane, with hurricane force winds extending outward up to 80 miles from the center and tropical storm force winds extend outward up to 275 miles. After maintaining this intensity for several hours, Earl weakened to a Category 1 hurricane again at 1500 hours UTC on September 10, then transitioned into an extratropical low south of Cape Race, Newfoundland 6 hours later. 2 people died on September 4 in Salinas, Puerto Rico, after being struck by lightning while riding a jet ski. Bermuda was buffeted with sustained winds of 35 miles per hour as Hurricane Earl passed within about 90 miles of the island's eastern coast. Higher gusts were reported, including one of 67 miles per hour at the National Museum of Bermuda. There were localized power outages across the archipelago but no large-scale damage was observed. During a 36-hour period September 10–12, 7/8 in of rain fell in the St. John's area, causing overflowing along the Waterford River which led to urban flooding. Similar rainfall amounts were also reported in communities throughout the Avalon Peninsula. Additionally, the cyclone caused rough surf which damaged the breakwater on the coast in the area of Trepassey, Newfoundland, and Labrador, causing localized flooding. Hurricane Fiona. Early on September 12, the NHC began to monitor a tropical wave over the central tropical Atlantic for gradual development, though environmental conditions for development were assessed as only marginally favorable. Even so, shower and thunderstorm activity within the disturbance began to become more concentrated later that same day, then increased and became better organized during the next day. The circulation associated with the system became more defined and persisted overnight and into the morning of September 14, attaining sufficient organization to designate it as Tropical Depression 7 later that day. Despite the continued effects of moderate westerly shear and dry mid-level airflow, new satellite imagery indicated the depression had strengthened, thus at 1:45 UTC on September 15, it became Tropical Storm Fiona. The storm moved over Guadeloupe as a 50 miles per hour tropical storm around midnight UTC on September 16 and then entered the eastern Caribbean. Early on September 18, the storm strengthened into a hurricane as it approached Puerto Rico, before making landfall there that afternoon about 15 miles south-southeast of Mayagüez, with maximum sustained winds of 85 miles per hour. It then emerged over the Mona Passage, and strengthened slightly further before making landfall near Boca de Yuma, Dominican Republic, with maximum sustained winds of 90 miles per hour. Fiona weakened slightly as it moved overland, but began to rapidly strengthen once back over water, becoming a Category 2 hurricane by 2100 hours UTC on September 19, and then a Category 3 major hurricane early the next morning near Grand Turk Island. Further intensification resulted in it reaching Category 4 strength with maximum sustained winds of 130 miles per hour at 6 o'clock UTC on September 21, while moving northward across very warm waters with surface temperatures of 84–86 degrees F. Fiona's winds then held steady for a couple of days while its central pressure dropped to 932 bar at midnight UTC on September 22. The hurricane's peak intensity as a tropical cyclone. Fiona's wind field also began to grow in size and tropical storm strength winds impacted Bermuda for several hours on September 23, despite Fiona passing well west of the island. Fiona, weakened to a Category 3 hurricane that morning, but briefly rebounded to Category 4 strength several hours later as it moved northeastward at about 35 miles per hour, before weakening once more to a Category 3 strength late that same day. Shortly thereafter, Fiona weakened again before turning northward and quickly transitioning into a large and powerful post-tropical cyclone as it approached the coast of Nova Scotia at 3 o'clock UTC on September 24. Soon thereafter, the system made landfall in eastern Nova Scotia 7 o'clock UTC with 100 miles per hour winds and a pressure of 931 bar, slowing rapidly as it did so. It then moved over Cape Breton Island with hurricane-strength winds, although it continued to weaken as it moved northward. When the NHC issued its final advisory on Fiona at 2100 hours UTC that same day, it was centered about 80 mi northwest of Port Auxiliary Basques, Newfoundland, and had maximum sustained winds of 70 miles per hour. Fiona would continue to weaken as it moved erratically northward into the northwestern Atlantic before dissipating west of Greenland over Baffin Bay on September 28. Altogether, at least 22 deaths have been attributed to Fiona. One death was confirmed in Guadeloupe, while at least 2 deaths were confirmed in the Dominican Republic and 3 in Canada. In Puerto Rico, as of September 24, the Department of Health had confirmed 16 deaths related to the path of the system. Still recovering from the effects of Hurricane Maria in 2017, torrential rains fell island-wide on September 18-19, up to 25 in some regions, causing destructive flash flooding that washed out roads and bridges. In addition, the effects of the storm resulted in the island-wide power grid being knocked out. In Canada, homes and businesses across the Maritimes, Quebec's north coast and Newfoundland were destroyed and several 100,000 people were left without power in Fiona's wake. Tropical Storm Gaston. A tropical wave moved off the coast of West Africa into the tropical Atlantic on September 12, producing disorganized showers and thunderstorms, but doing so in an environment just marginally favorable for development. By September 15, the wave had moved generally westward to about midway between Africa and the Lesser Antilles. There the showers and thunderstorms continued within the northern portion of the wave. The disturbance then transitioned into a trough of low pressure on September 17, as it moved slowly northward. After showing little signs of development over the next 2 days, a low pressure formed within the trough and convection began to organize around it. Upon producing a well-defined center and persistent deep convection, became Tropical Depression 8 at 1500 hours UTC on September 20. The depression strengthened into Tropical Storm Gaston 6 hours later while it was located about 990 miles west of the Azores. Gaston quickly intensified, attaining peak sustained winds of 65 miles per hour the following day, just 18 hours after formation. However, additional strengthening was prevented as dry air became entrained into the eastern portion of the circulation. Gaston then maintained its intensity for 2 days as it accelerated northeastward toward the western Azores despite being in an environment of moderate to strong shear, relatively dry air, and cool sea surface temperatures. On September 23, Gaston began to interact with a shortwave trough/baroclinic zone, which shunted all of the deep convection to the northeastern portion of the storm, and it weakened slightly as it slowed down and began an anticyclonic loop through the central Azores along the southern side of a mid-level ridge. However, Gaston re-strengthened later that day as convection reformed over northern and western sides of its circulation, and it reached its peak intensity with sustained winds of 65 miles per hour and a minimum barometric pressure of 995 bar at 1500 hours UTC. Relentless wind shear then stripped Gaston of its deep convection, and the storm began to weaken again early the next morning as it continued its loop, which it completed later that day as it passed just west of the Central Azores. Now moving westward away from the Azores, Gaston dropped to minimal tropical storm strength, but re-strengthened for a third time as a large burst of convection developed over the northern portion of the circulation as it interacted with an upper-level trough. Its winds increased to 50 miles per hour on the morning of September 25 and it maintained this intensity for most of the day as its center reformed under the convective mass. However, Gaston soon moved away from the trough and wind shear quickly removed the remaining deep convection from the storm late that afternoon. Convection did not reform over Gaston and it weakened for the final time before being declared a post-tropical cyclone at 3 o'clock UTC on September 26. Heavy rainfall and tropical storm force winds were reported across the Azores, especially in the western and central islands. A weather station at Horta on Fayal Island measured a wind gust to 41 miles per hour as Gaston passed through. Hurricane Ian. On September 19, the NHC began tracking a tropical wave to the east of the Windward Islands for possible gradual development. 2 days later, the disturbance passed over Trinidad and Tobago as it entered the southeast Caribbean, and then near to the ABC Islands and the northern coast of South America. On September 22, while moving west-northwestward, it showed signs of increasing organization, though strong wind shear of 30-35 mph generated by the upper-level outflow from Hurricane Fiona was inhibiting development of a tropical depression. Even so, a well-defined circulation was able to form within the disturbance that day. Its convection then increased and become persistent overnight into the next day, resulting in it being designated Tropical Depression 9 early on September 23. The organization of the depression improved slowly over the course of that day, and it became Tropical Storm Ian at 3 o'clock UTC on September 24. The high wind shear from Fiona was gone completely by the next day, as the storm entered the central Caribbean where it encountered wind, water, and atmosphere conditions favorable for intensification, light wind shear, warm 86 degrees Fahrenheit sea surface temperatures and a mid-level relative humidity of 70%. In this environment, Ian quickly became better organized and strengthened into an Category 1 hurricane at 9 o'clock UTC on September 26. 12 hours later, it intensified into a Category 2 hurricane as it approached the western tip of Cuba. At 8:30 UTC on September 27, Ian made landfall near La Coloma, in Pina del Rio Province, Cuba, as a high-end Category 3 hurricane, with sustained winds of 125 miles per hour. After about 6 hours over land, Ian emerged off the north coast of Cuba into the Gulf of Mexico, still a major hurricane though a slightly weaker one. Later, overnight September 27-28, the hurricane moved directly over dry Tortugas National Park in the Florida Keys with sustained winds of 120 miles per hour, as it was undergoing an eye replacement cycle. Once that cycle was complete, Ian rapidly strengthened, reaching Category 4 intensity on the morning of September 28, according to data from a reserve Hurricane Hunter aircraft, with its maximum sustained winds rising to a high-end Category 4 speed of near 155 miles per hour by 10:35 UTC. Later, at 19:05 UTC, Ian made landfall at Cayo Costa Island, with winds of 150 miles per hour. And then, an hour and a half later, on the Florida mainland, just south of Punta Gorda, with maximum sustained winds of 145 miles per hour. It then proceeded across central Florida before moving offshore into the Atlantic Ocean at 1500 hours UTC near Cape Canaveral as strong tropical storm. At the time, the storm was exhibiting some extratropical characteristics, such as a comma pattern and some frontal features in its outer circulation. Even so, it remained a hybrid tropical cyclone as it maintained a warm core. Later that day, while making a turn to the north-northeast, Ian re-intensified into a hurricane as it moved over the Gulf Stream. The system turned northward on morning of September 30, and accelerated. During this time, deep convection redeveloped near the center of the storm and the frontal features moved away from its core. An eye wall also began to form around a portion of its circulation. At 18:05 UTC that same day, Ian made its third landfall near Georgetown, South Carolina, with sustained winds of 85 miles per hour. Ian began to weaken inland, and transitioned into a post-tropical cyclone over coastal South Carolina 3 hours after landfall. The cyclone later dissipated over southern Virginia late on October 1. While in the early stages of developing, the system brought gusty winds and heavy rain to Trinidad and Tobago, the ABC Islands and to the northern coast of South America on September 21, 22. Ian killed 5 people in Cuba. It also caused extensive damage to homes, factories, roads and tobacco farms throughout the region. Power was initially knocked out throughout 3 provinces, but later the nation's entire electrical grid collapsed. The highest 24-hour rainfall total recorded was 4.3 in at a weather station on Isla de la Juventud. Significant storm surge inundation occurred along the coasts of the Gulf of Guanajuato and Isla de la Juventud. As of October 6, more than 120 people have died in Florida as a result of the hurricane, including 49 in Lee County where it made landfall. It also includes 7 Cuban migrants who drowned when their boat capsized off Stock Island as Ian moved through the Florida Keys. 11 others were still missing. Numerous tornadoes touched down in South Florida on September 27, as Ian approached. Ian inflicted catastrophic damage in southwest Florida, washing out roads and bridges, toppling trees, and destroying homes and businesses. Hardest hit was Lee County, where damage from the hurricane's 145 miles per hour winds was exacerbated by a storm surge which peaked at 7.25 feet at Fort Myers. Inland, where significant flooding occurred, Orlando recorded a record-breaking 24-hour rainfall total of 12.49 in, and further east on the Atlantic coast, an amateur weather observer near New Smyrna Beach reported 28.60 in of rain in 27 hours. Later, in South Carolina, Ian caused far less property damage, and there were no reports of casualties from the storm there. 5 storm-related deaths were, however, reported in North Carolina. Ian's remnants also contributed to coastal flooding along the mid-Atlantic coast. Tropical Storm Hermine. On September 22, a tropical wave being monitored by the NHC emerged off the coast of West Africa into the tropical Atlantic east of Cabo Verde. It quickly organized, becoming Tropical Depression 10 at 1500 hours UTC on September 23, and then strengthened into Tropical Storm Hermine 6 hours later. It is one of few tropical cyclones on record to form this far east, and to track between the Cabo Verde Islands and the coast of Africa. Development beyond a weak tropical storm was stymied by southwesterly shear into the next day, as it moved northward. On account of the shear, Hermine weakened into a tropical depression at 2100 hours UTC on September 24, and then degenerated into a post-tropical low the next day. Offshore, several migrant boats from the Western Sahara ran into the storm. One carrying 34 people became stranded and 33 of the occupants were lost while one was rescued. Hermine brought heavy rainfall to the Canary Islands, causing localized flooding and downed trees. More than 140 flights were cancelled across the archipelago. Damage across the archipelago exceeded €10 million. Tropical Depression 11. Early on September 21, the NHC began to monitor a tropical wave located west-southwest of the Cabo Verde Islands for possible gradual development. The wave evolved into a broad area of low pressure later that same day, but the disturbance remained embedded within a dry air environment along with unfavorable upper-level winds, and little to no organization occurred over the next few days as it meandered over the central tropical Atlantic. Convection around the low-pressure area gradually began showing signs of organization on September 26, and finally developed into a tropical depression at 1500 hours UTC on September 28. Despite an overnight burst of deep convection, the depression remained poorly organized on September 29, and began to deteriorate. By 2100 hours UTC that same day it had degenerated into a post-tropical remnant low. Tropical Depression 12. Early on September 29, the NHC began to monitor a tropical wave moving off the west coast of Africa, which was producing a broad area of showers and thunderstorms and moving into an environment conducive for gradual development. The disturbance remained disorganized for the next few days as it moved over the eastern tropical Atlantic to the south of the Cabo Verde Islands. It became better organized on October 3, as the convection around the center of it began to expand and the upper-level outflow increased. The next day, a small circulation around a well-defined circulation developed within the disturbance, resulting in it being designated Tropical Depression 12. The cyclone struggled to maintain organized deep convection throughout the day on October 5, due to persistent southwesterly shear. The depression deteriorated further the following day, degenerating into a surface trough by 3 o'clock UTC on October 7. Hurricane Julia. On October 2, the NHC began monitoring a tropical wave over the central tropical Atlantic for possible gradual development. A broad area of low pressure with an ill-defined center formed within the wave on October 4, as it approached the southern Windward Islands. A Hurricane Hunter mission into the disturbance the following day found tropical storm-strength surface winds, but determined that it did not have a well-defined circulation center. Due to the threat the developing system posed to land areas in the southern Caribbean, the NHC initiated advisories on it as potential Tropical Cyclone 13 on October 6. Later that day, after satellite imagery and radar data indicated that the disturbance had attained sufficient circulation and organized convection, and after Hurricane Hunter's survey data showed the presence of 30-35 mph winds north of the center, it was designated as a tropical depression. A strong burst of deep convection developed near the center of the depression as it moved across the Guajira Peninsula in the early morning of October 7, and soon afterwards, it strengthened into Tropical Storm Julia over the adjacent southwestern Caribbean. Afterward, the morning burst of deep convection was stripped away by northwesterly shear, and the storm's low-level center was exposed for the next several hours. Even so, Julia retained tropical storm intensity. When the shear diminished, there was an increase in persistent and deep convection over the center, and the storm began to gain strength. Julia became a hurricane at 2300 hours UTC on October 8, and, about 8 hours later, made landfall near Laguna de Perlas, Nicaragua, with estimated sustained winds of 85 miles per hour. The system then gradually weakened to a tropical storm as it moved westward across the rugged terrain of Nicaragua, though it maintained a well-defined circulation and deep convection persisted near the center. Still intact, Tropical Storm Julia crossed into the eastern Pacific Basin at 2100 hours UTC on October 9. On October 5, the disturbance brought heavy thunderstorms to several of the Windward Islands and the Caribbean coast of South America. More than 2 in of rain fell in Trinidad and Tobago in less than a half hour, causing significant flash flooding. A few days later in Venezuela, the heavy rain caused widespread flooding and landslides. In Las Tiguerillas, in north-central Venezuela, at least 54 people died and 50 went missing when mud and debris inundated the town. In Central America, flooding and landslides caused widespread damage along with numerous fatalities, causing and at least 4 people have died, 3 in Honduras and 1 in Panama. Altogether, at least 91 deaths are being attributed to Julia. In addition to the 54 deaths in Venezuela, it is blamed for 14 deaths in Guatemala, 10 in El Salvador, 1 in Trinidad and Tobago, 5 in Nicaragua, 2 in Panama, 4 in Honduras, and 1 in Mexico. Tropical Storm Karl. On October 10, the NHC began to monitor an area of disturbed weather located north of dissipating Tropical Storm Julia. The low later moved over the Bay of Campeche, where conditions were conducive for further development. There it became organized and rapidly strengthened into Tropical Storm Karl at 2100 hours UTC on October 11. A hurricane hunter's mission into the storm the following morning found that Karl's sustained winds had increased to 60 miles per hour as it moved slowly northward. However, increased wind shear began to weaken the storm early on October 13, and it stalled over the southwestern Gulf of Mexico. Nonetheless, Karl's central pressure began to fall slightly after it began moving south-southeastward as the day progressed. Moderate northwesterly shear and drier mid-level air continued to inhibit Karl from strengthening on October 14, as it moved toward the coast of southern Mexico. Satellite images that morning showed that the dense overcast around the storm's low-level center had become more symmetric overnight, with its heavy thunderstorms concentrated to the southeast of the center. By that afternoon, the dry air and wind shear had taken their toll, snuffing out Karl's last burst of deep convection, after which it weakened to a tropical depression, and then deteriorated into a remnant low at 9 o'clock UTC on October 15. Karl caused significant flooding in southern Mexico, which damaged homes, businesses, and bridges throughout the region. The heaviest rainfall occurred in Tabasco and neighboring Chiapas. Camoapa, Tabasco, recorded 15.3 in of rain in 24 hours on October 14-15, while Rio de Janeiro, Chiapas, recorded 13.5 in during that same period. Numerous families had to be evacuated from their homes because of the flooding, which also forced the evacuation of more than 1,000 people attending a religious event in Picuicalco, Chiapas. Additionally, 3 storm-related fatalities were reported in Chiapas, 1 in Picuicalco and 2 in Juarez. Tropical Storm Lisa. On October 28, a broad area of low pressure developed over the southeastern Caribbean, producing a large area of disorganized showers and thunderstorms. Early on October 30, data from 2 Hurricane Hunter aircraft missions into the disturbance showed that the low center of circulation was becoming better defined and that it was producing winds of 35–40 mph to the north of its center. As a result, and due to the threat the developing system posed to land areas in the central Caribbean, the NHC initiated advisories on it as potential tropical cyclone 15 later that day. The disturbance became organized as Tropical Storm Lisa at 1500 hours UTC on October 31, south of Jamaica. At the time, most of the storm's heavy thunderstorm activity was occurring to the east and south sides of the center as a result of westerly wind shear. Current storm information. Watches and warnings. Other systems. On August 15, the NHC first noted the potential for tropical cyclone development in the southwestern Gulf of Mexico from a tropical wave that was located over the central Caribbean Sea. The low emerged over the Gulf early on August 19, producing disorganized showers. Due to the threat the developing system posed to northeastern Mexico and South Texas, the NHC initiated advisories on it as potential tropical cyclone 4 at 2100 hours UTC that same day. As the disturbance moved northwestward toward the Gulf Coast of Mexico on August 20, a Hurricane Hunter's mission found that it was still a surface trough. Later that day, it moved inland, striking the coast about 60 miles southwest of the mouth of the Rio Grande. With that, the window of opportunity for tropical development closed, and the NHC issued its last advisory on the system at 3 o'clock UTC on August 21. The disturbance brought heavy rain to coastal Tamaulipas and coastal South Texas. Storm names. The following list of names is being used for named storms that form in the North Atlantic in 2022. Retired names, if any, will be announced by the World Meteorological Organization in the spring of 2023. The names not retired from this list will be used again in the 2028 season. This is the same list used in the 2016 season, with the exceptions of Martin and Owen, which replaced Matthew and Otto, respectively. Season effects. This is a table of all of the storms that have formed in the 2022 Atlantic hurricane season. It includes their duration, names, landfall denoted by bold location names, damages, and death totals. Deaths in parentheses are additional and indirect, but were still related to that storm. Damage and deaths include totals while the storm was extratropical, a wave, or a low, and all of the damage figures are in 2022 US dollars.